Okay, what do they have to multiply to? They have to multiply to the number on the end, but they have to add to the number in the middle. How do I remember this? Spell the word man. Where does the A go? Right here in the middle. This is how I remember this, right? So if the A goes in the middle for man, then you put it here, right? You know the two numbers have to add to 6, but they have to multiply to 8. I don't know why I wrote 8. They have to multiply. Okay? Now, the game begins. You're trying to find the two numbers that make these two conditions work. Right? So you're going to say, okay, I need two numbers that multiply to 8. Let's just start here. 1 times 8. 1 times 8 equals 8 when you multiply them. Okay, so that works. But 1 plus 8 does not equal 6. So that doesn't work. Okay, so that's a problem. That means that the numbers 1 and 8 are not going to work. So you're going to go to the next stage. This is how I just operate through this, right? What are the next two multiples that you can multiply together? What about 2? I'm counting up. 1 to 2. Does 2 go into 8? Yes, it does. How many times? 4. 2 times 4 equals 8. All right, good. 2 plus 4 equals 6. Oh, look at that. All right, well, that must mean, and this is kind of, these are the two numbers that work. They're both positive. What do? You take whatever variable you're using and you write the variable in front of these two numbers. These are your lengths and widths. X plus 2, x plus 4. Let's take a minute and prove that to ourselves. Okay, we'll delete these. Okay, let's just build this question. X squared, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's build a perfect square or rectangle. Sorry. 1 there, 2 there, 3, 4. All right, and you're like, okay, well, I'm gonna start slotting some of these in here, maybe, right? Because I don't want to put them all up. You can put them all up, but you know as well as I do now, almost, after doing a couple of these, you're going to have 2 left over here. Right? You're like, oh, what am I going to do? Okay, well, now I'm going to have to start dragging these back and building the bottom. All right. Well, now I have 3 left over. Well, let's drag another one. Okay, and then you say, oh, how do I factor this? Or how do I, what's the rectangle look like? Well, what are the lengths and widths? You say x plus 4, right? Because you could fit, oh, let me, just so there's no confusion, what can I put up here? An x, right? And then 4, right? That's what fits here along the top. What fits down the side? Well, you can put an x here. And 2. What are my side lengths? X plus 4. X plus 2. Well, this looks a lot like what I just did over here. All right? Right here. Okay? My point is, when you guys go to try these questions, as the numbers get bigger, and there will be some bigger numbers on your homework questions, okay, sometimes you don't want to build those with the Mathagon stuff. I mean, it'll work, right? And the nice thing about Mathagon is that you guys don't have a limit to how many of these you can put down, right? So that's nice. Whereas like in a classroom, like if I only gave you a package of algebra tiles, like you might only have 10 of these things in total, right? And so then you'd be stuck, right? So I show you this over here because this is the algebra stuff, and we need to know how to do this for the bigger questions. Okay. This idea of this man method is very important. Okay. You find two numbers that satisfy these two conditions. Right. Okay, I'm going to do one more with you, and then you guys will be good to go and do some questions. Okay. So here we go. I don't necessarily want to build this one, so let's do the man method. Okay. So I'm going to need two numbers that multiply to 9 and add to 6. Right. So I'm going to say, okay, multiply to 9, add to 6. These numbers they're still not big enough such that you couldn't use the tiles or the Mathagon. Okay, you could go build this if you wanted to, and I'd be okay with that. If on a formative you guys want to go build this and then take a picture of it and then upload it, I'm fine with that, right? But I want you to actually write down underneath, I want you to write this answer. Okay? But I promise you on the quiz, just so that I know that you can do this stuff, I'll probably give you one question that you could probably build like this, and then one that you couldn't, where the numbers are just a bit bigger. Okay? So we have to find the two numbers that are going to work here. So how do I do that? Well, I always start with the smallest multiple, 1. You can multiply anything by 1, right? Sometimes that one works, but 1 times 9, right? That equals 9, right? That's okay. We needed to do that. But 1 plus 9 equals 10. Okay, so 1 and 9 aren't going to work. Well, then you go to 2. Well, you can't multiply anything by 2 that's even, right? Like not even by in the stand, like it's a whole number, sorry. Can't multiply 2 by a whole number and get 9. So which means it's not going to be 2. Like you get to ignore that, right? Then we go to 3. 3 times what gives me 9? 3 times 3 equals 9. Oh, that's good. That works. 3 plus 3 equals 9. Sorry, 6. Silly. That works too. So look at that. These are the 3 and 3 are my numbers. Well, not like that. Don't write that. 3 and 3 are my numbers. What do you do with that? Well, they're both positive. So you just get to take whatever variable you're using, in this case x, and you're going to go, oh, this fact, we call this, I'll explain this in a sec. You take this and you go, right? And you say, okay, I have 2 of the same thing, so I can condense it. We already saw one of these earlier. It would have created a perfect square. So here's how it turns out. Okay. Building rectangles. Another way to say building rectangles, factoring. And what it wants to do is it'll say factor, right? Which basically means find the length and width. That's what this means. Now, if you guys think back, just to tie this all together for you, if you guys think back to this morning's lesson, we talked about, at the very, very first thing we did today, we talked about the 3 different forms. This right here, I want you guys to look at this. Or this one. Right? That looks like this. Right? Remember I wrote down on the sheet this morning, factored form. What did factored form look like? It looked like this. Y equals a x minus a number, x minus a number. So in this question, we would have, well, I want to get into that. I won't get into that. Okay, but it looks like this. This looks like this. A value is going to be 1, and then we're going to have x plus 3, x plus 3. Okay, this is factored form. Okay, which we're going to use for something, but you guys have to know how to take something. You remember, this was standard form, where y equals ax squared plus bx plus c. A, b, and c were just numbers. 1, 6, 9. Okay?